Hey everyone, welcome back to another video. I'm starting a new series where we'll be building a Rust command line tool, and this will be used for password management, password generation, and encryption, and so on. The main goal of this project is to help beginners understand what it's like to build in Rust and getting a feel for reading Rust code and contributing to open source projects in it. By the time you watch this video, I'll have created a bunch of good first issues on this project that we're about to build. So you can go ahead and check out the link in the description to the GitHub repository and clone the repository, play around with it a bit, and try to work on an issue or submit new issues to the code. The main aim is to give you guys a head start into a project with a guided series that builds the foundation of the project from scratch. In this video, we'll be setting up the project from start and creating like a basic CLI, as well as setting up the password generator for our project. So without any further ado, let's get started. So I've created an empty repository. It's called Lockbox. That's what I've decided to call this project. And in here, I'm going to initialize a new cargo project. If you don't know what cargo is, by the way, it is a build system and a package manager for Rust. It will help you create new projects. It will help you manage dependencies of your project. And so this has created a new folder with the project name, and it has an SRC with a main.rs. Let's just cd into the project. So it initializes Git out of the box, and inside the SRC we have a main.rs which will just have a hello world program in Rust. If we just do a cargo run, we should see a hello world here. Now, this is where we will write our whole project within the SRC. And the target that's generated here, you don't need to interact with this directly, but it has all the files, all the dependencies, and so on, which will help run your binary. And the cargo.toml file, this will keep track of all of the dependencies that we have for our project. So first things first, we need a CLI for our project. We need a way to pass in flags and arguments and values to our programs. The most basic way of building something that will read arguments from the CLI would just be to use the standard library. There's a standard env that's provided by Rust, which will have a way to collect arguments from the CLI. We were to do a cargo run, and we can have two hyphens, and whatever we provide after the hyphens is given as arguments to the program. So if we were to do something like add service email password, something like this, and we want to store this password in our password manager, then we would see those arguments printed out. So the first argument is the binary that we're executing, and then all of the arguments that we pass to our binary. And the next step would be to parse all of these arguments. So we would have to check what's the command that's passed here. So we want to add something or we wanted to remove something. So the first argument would be that. The second flag, we would need to parse this separately. And the value, so something like a key value, we'll need to implement this parser from scratch. And we don't want to do this. There's a crate that we can use that will help make our lives easier. It's called clap. If you go to crates.io and search in clap, you'll see this crate here. And this will help us easily create a command line parser, which will just parse all of the flags for us, parse the sub command that we're giving to the CLI. This is essentially like a dependency that we're adding to our project. And to do that, we would just do cargo add clap. And this will add the dependency to our project. If we were to go back to our cargo toml, we would see that clap has been added as a dependency. Now, the cool part about cargo is that it will not install all of the features from the flag. As you can see, all of these features have not been installed automatically when we did a cargo add clap. We only added these features from the package, and we really want the derived feature from the package in order to build our CLI easily. So to install that feature, we can do a cargo add clap and features derived. And this will add the derived feature from the package for us. And now we can use this feature. So we'll first need the parser from clap, and we'll create an arg struct. A struct is essentially like a class in other languages, and we'll derive the parser into the args. This is why we installed the derived feature of clap. So inside here, I'm going to have a command item. The command here will basically be the add or the remove or the list or the sub command that we're providing for our CLI. So this will be the main operation that we want to perform. I'm going to create an enum called command, and this will be what command represents. And inside here, we can have all of the different commands that can be provided for our CLI. Just like our args, we need to derive the parser for the command as well. And we'll need to mention that this is a subcommand. You can reference the documentation for clap, by the way, for all of the syntax that I'm using here. So since args is the main entry point for our CLI, we can also provide a name for the CLI and an about. So that's what I've added here. I'm just keeping it simple for now. So for now, I want to perform all of these operations with our CLI. So let's start with the add subcommand. For this, we will need to provide a bunch of flags. So the first flag I want to be able to parse is the service flag and also a password flag. Now for both of these, I want to allow, let's say, a service flag like this and also a short service flag like this. To do this with clap, we just provide the short and the long. I also want to have an optional username field. So if I wanted to have a particular username within my email, I would be able to store multiple passwords for emails, and this one would be specific to that email address. Now, for this video, I'm not going to go into much detail about the add, the list, the remove, the show, all of these operations. I'm not going to discuss them in this video, probably in the next video, but for this video, I'm just going to implement the generate command. So within generate, I want to be able to take in a length for the password, and this will be an enum. So I'm going to provide like a few options for the length. This is the length enum that I've created. Also, we'll need to implement value enum. Value enum is a trait within the clap package, and this will help us provide what possible values can be returned by the enum. So for instance, we are having 8 as just 8 here, and we want it to be returned as the string 8, and we provide all of the different variations that the enum will have. Once we do that, the error should probably go away, and it did. I want to provide a default value for our length as 16, and to do that, we'll need to implement display for our length enum. So just like we implemented value enum, we'll also implement display for length, which will have a function named format. In here, we'll have a match statement with self. This is similar to a switch case in other languages. So for 8, 16, and 32, we want to have a string value for 8, 16, and 32. So once we've done that, we are now able to provide a default value for our length as 16. The other possible flags that I want to accept from the CLI for the generate subcommand is the symbols, the uppercase, the lowercase, the numbers, and the count. So if you were to now pass in some kind of a command, it wouldn't work because our main function is empty. We need to parse the incoming commands that we are getting. To do this, we'll need to figure out what the entry point of our command line is. And in this case, it is the args struct. So we'll just do args parse. So we can collect the arguments that are passed into an args variable. And now we can have like a match statement with this args, and this will be one of the values in our enum. It can be either be add, generate, list. So this is how we add a case to the match command, and we provide all of the different values that we are expecting. And inside here, we would write the logic of how we want to deal with each of these commands. So there we go. I've added all of the possible commands that we have in our command enum. I'm not really going to implement the add for now. That we'll handle in the next video, but for now, we just want to generate a password. In here, I'm just going to add a print line with all of the possible values that we're able to pass. So there we go. I've added a print line. So if I just pass an empty generate command, we see that we are passing a length of 16, which is the default value that we have provided. We haven't really passed any flags, so I'm just going to pass a count of 8, and we see that the count is overridden. So this is a really cool crate that will let us generate passwords. And if we go ahead and look at the repository, the way this works is that it loops over the length of the password that we need, and it randomly picks the characters out of all of these lists. There's a lowercase letters list, there's a symbols list. It randomly picks out of them just like this. So we can add that to our project, cargo add passwords. So this is going to be pretty easy generating passwords, which is why I'm putting this in the first video. I'm going to import password generate out of the crate. And inside here, I'm going to create a new password generator, provide the length, the lowercase letters, uppercase letters, and all of the values that we need. I'm providing strict here because strict will just ensure that at least one symbol is added to the password, at least one number is in it, and so on. The reason why we are not able to directly pass the length here is because length is an instance of the enum. So we can create a function in our length enum, which will just return us back the integer value of the length, implement length, and in here we can have a get val. So we're going to match over all of the values of self, return back a usize. And now we see that the error has gone away. So what I'm doing here is I'm matching on the password generate, and if a password is generated successfully, then I'm just printing that password. Now let's try to generate a password. Then we see that a random password is generated for us. If we were to pass in a length of 8, then we would see an 8-character password. Now, we're not using our count variable here because I haven't really implemented that part. So if we want to generate more than one passwords, then we need to check right here if count is greater than one. If it is, then we'll handle it separately. And in the else case, we can put all of this logic that we just wrote down. So if we are looking for more than one passwords, then we will probably run a loop here, or there's a pretty cool generate method within the password generator, which just takes in the count argument. So we'll need to do a similar match statement that we are doing here as well, but instead of just printing out the passwords directly, I'm going to loop through the passwords that were generated and print all of them one by one. If I were to generate 32 length 7 passwords, then we should get 7 passwords. So in this video, we went through how we can set up the CLI and how we can generate the passwords. Again, if you're interested in the project and if you're looking for Rust projects to contribute to open source projects where you want to kind of go through the code base and understand what's going on, contributing to projects, then feel free to go over the link in the description for the repository to this code base. So anyway, if you like the video, leave a like, and I'll see you in the next video. Bye bye.